Hello everybody. So far in our course we studied initial nuclear properties, then nucleus properties, then we focused on the nuclear stability and binding energy curve approximations, and then we studied some X-ray emission as well as mass spectrography in the first unit, and we did discussed the interaction of particles and radiation with the matter, and we did ample discussion on the radiation interaction with matter, like gamma rays interaction with matter. Then I told you and I gave you an assignment in which you had to do that photoelectric effect, Compton scattering, and pair production. So in moving forward, because those topics are not as much important, and you already studied those topics in the last semester, so you can do those topics on your own as well. So as moving forward, we are going to discuss alpha disintegration, or I can say alpha decay, any particular radioactive element. Most oftenly, if I say you that the radioactivity happens for atomic number greater than 83 and atomic mass greater than 209. But the most important thing is that higher we discussed nuclear stability curve. In that curve, in the nuclear stability curve, the most important curve, if I say you, let's try it again. In the nuclear stability curve, right, if this is the nuclear stability curve and with respect to Z, and this was the n is equal to Z line, and the number of nucleus having more number of neutrons fall on this particular region, and this is the nuclear stability line. For this case we got alpha decay, beta decay. For this also beta decay we got, but here the nucleus which resides here, it will emit as a alpha decay, because in alpha decay maximum amount of mass changes. The daughter nuclei has lower amount of mass, and that decreases by a factor of 4, and from the parents nuclei. So alpha disintegration or alpha decay is the most important kind of decay. There are three modes of decay. First one is alpha decay, second beta decay, and then the last one is gamma decay. But this is not certainly inevitable. This is not the important thing, that which decay will first happen and which decay will happen at last scenario. Alpha decay can happen initially, and then the daughter nuclei can spontaneously convert into different, then this is also known as successive disintegration. So anything can happen, like beta decay, or like beta positive, beta negative, like alpha decay and all this. So alpha decay or alpha disintegration is an important thing. So this is impossible, that alpha decay is completely inexplicable by classical mechanics. So we cannot use classical mechanics here. Like if there is inside the nucleus, there is alpha particle of you can assume alpha particle of charge, not assume alpha particle of 2 unit of charge and 4 unit of mass, and the rest of the nucleus has Z minus 2 unit of charge. Then the energy of interaction between alpha particle and that rest of the nucleons is very much high. This is nearly about 25 mega electron volt, and when alpha particle comes out, it has a kinetic energy of about 5 to 6 mega electron volt. So if alpha particle has this much less energy, then it should have been larger energy. Then how this is coming out, how this is escaping from the system? So this is very much indeed we are going to discuss that today. So classical mechanics, this is not possible, because according to classical mechanics, if this is the kinetic energy only, I am drawing a graph of energy with respect to distance. If classical mechanically, if particle has an energy of this range only, and potential has this range, potential barrier has this height, then particle cannot penetrate this, right? Because potential is too much high, that particle is bound to be inside the nucleus. So if I consider consider this, that this is nucleus, and inside nucleus this is alpha particle having 2 unit of charge plus 2e, and rest is z minus 2 charge here. So the interaction and bound state of this, we can find out the potential, right? Potential from here, and that comes out to be 25 mega electron volt. If this is 25 mega electron volt and this particle is coming out and has an energy of only 4 to 5 mega electron volt, then how this is possible that this alpha particle can come out from this? So classical mechanically this is not possible. So if this is the potential bound, particle cannot come out, particle cannot penetrate this barrier, right? We can consider a simplest example, like if a wall, if I hit a part, if I hit by with a bullet, the bullet will penetrate only the kinetic, because mass is very small and the velocity is very large, so kinetic energy is very enough high that kinetic energy can penetrate the wall. But if I throw a ball has a little high mass but not enough velocity, that the kinetic energy is smaller enough than the potential, ball will strike the wall and will come backward. So this is not possible, the collision. So or I can say that particle cannot penetrate according to classical mechanics if this does not have, the particle does not have enough energy. Then how do we study this? Actually, alpha decay is possible by quantum mechanics. Alpha decay is explained by quantum mechanics, but in 1928 George Gamow explained alpha decay, and he told alpha decay from the radioactive decay possibilities. He explained that there is a charged particle which is coming out as alpha particle 2He4, and that alpha particle, he did not explain that using quantum mechanics, because if we understand the explanation of quantum mechanics, the de Broglie wave duality and then Schrodinger equation, then those equation and those duality, those came later. Schrodinger equation came in 1927 and Gamow theory came out in 1928, but there was an explanation of Gamow theory of alpha decay. He explained that without using the Schrodinger equation, but quantum mechanics gives enough evidence with respect to that. So quantum mechanics actually allows us to understand alpha decay using the alpha decay, right? So how can we understand alpha decay? Actually, to understand this, we need to focus on the tunneling or tunnel effect. In tunneling, in the last semester we discussed this tunneling. But in tunneling, a potential barrier is there, and one particle can, if the particle is oscillating inside the potential system, oscillating means there is a oscillation system, the wave function is a oscillating one, okay? Then particle is penetrating this wall, there is a very less possibility or probability of particle to come out. We calculated this, we found out this, that there is an wave function outside the system as well, outside the potential as well. So if there is a wave function, then there is a probability lies as well. So because of that probability, however, that the probability is very small, but still there is a probability for particle to come out. And that in case of, if we consider the probability is very small, this is nearly about 10 raised to power 38 times. When particle hit the barrier 10 raised to power 38 times, only one time it will be successful to come out. So this is very small probability, but still there is a probability of alpha particle and to come out, and this happens. So quantum mechanics explain this, and quantum mechanics explain this using I draw a graph energy with respect to distance. So at the distance of r naught, and means the nucleus radii from this, if this is the nucleus, the potential is so far from till here, so the interaction is till here, and we know that the boundation of this, now this is saturated region, because there is a nuclear force exerting between these particles. the Coulombic repulsion force is very small. The between Z minus 2 and this, the Coulombic repulsion is very small. But there is a interaction between this directly to by using the nuclear forces. So the nuclear force is saturated one. After this, the particle will experience a repulsive force on itself. Okay, and the energy of interaction, the particle electrostatic repulsive force must be enough that this potential barrier can be penetrated classically. But quantum mechanics says that we don't assume like this that there is enough potential repulsive force or something like this. However, this is happening, but if the wave function is oscillating inside this, wave function is outside, wave function is also non-zero outside the system, then there is a probability. However, the probability is very small, but quantum mechanics explain this, and we already discussed this probability in tunneling effect. Okay, so in next lecture we are going to discuss energy decay, energy of alpha, energetics of alpha decay. Okay.